Today, it is my pleasure to welcome Matthew Rees. He'll be giving a talk today on feral cats and foxes and their interactions and how the extirpation of one of them, lethal control of one species, can affect the other. Matthew hails from northern New South Wales, did his undergrad here in Brisbane at QUT, did his PhD down in Melbourne, and now is up in Darwin working on a postdoc, but I think most of his work is still based in Southern Australia. With that, I will let Matthew take over and give us a overview of what he's learned during his work. And just want to say thank you for the opportunity to come and learn about your work, Matt.
Great. Thanks so much, Matthew, and everyone watching. Just get going. Alrighty. Yeah, so I'm in Darwin at the moment on Larrakia country. So I'd like to pay my respect to traditional owners here and to wherever you might be joining me from. Matthew, if my sound goes a bit weird, just let me know. I reckon it's about to bucket rain here as well, but we'll see how we go.
I think you're good.
Sweet. All right, so get this out of the way. So I'm going to talk about my PhD research, which I'm just finishing up, all about whether fox control leads to more cats, essentially. This is research I've been doing with the University of Melbourne, with my supervisors, Brendan Wintle, Bron Haradsky, and Alan Robley. And it's been a super collaborative project. I've had a lot of help from Jack Pascoe, Mark Lepar, and Emma Birnbaum from the Conservation Ecology Centre in Victoria in particular, and heaps of help and support and money and guidance from Parks Victoria and DELP agencies in Victoria who are implementing this fox control that I'm, so really appreciative. And I'm going to be sharing some data collected by Parksic and DELP. So thank you to them. And a lot of data I'm going to present today, I had a lot of field volunteers who helped me collect this data. And so I'm really appreciative of them. This is, a lot of people's hard work all together that I'm lucky enough to put my name to, but and so I'm going to be talking about my fieldwork in southwest Victoria, so in the Glenelg region, that's on Gunditjmara country, which I'd never been before. I think it's really underrated, a really special place. I really fell in love with it. And I also did fieldwork in the Otway Ranges, which is on the eastern Maar country. And I spent most of my time on Gunditjmara country, which is a section to the west, which is cool temperate rainforest and wet forest, and a pretty difficult place to work. Always wet, always covered in leeches. But yeah, I think if you've been down this way, I think you'd agree that it's pretty incredible. So I'm really glad I got to spend time in this country, and I want to pay my respects to the traditional owners here as well. And I hope that this PhD research can help in the management in some small way. Alrighty. So invasive foxes occupy most of Australia, and they are having a really negative effect on our native animals. So things like the southern brown bandicoot and the long-nosed potteroo, they eat them, and that's bad, and they're struggling. And so often a really common conservation strategy across Australia is controlling foxes through 1080 poison baiting in particular, across broad sections of the landscape. And so 1080 kills the foxes, and thereby you have an indirect positive benefit to the prey. Like that's why we do it, and that's good. However, across the entire distribution of foxes in Australia, there are cats. And so cats and foxes occupy a really similar niche, functional niche. And so they're massive competitors, and foxes are also a little bit bigger. So we kind of think that that foxes might be suppressing feral cats. They might be aggressive towards them because they are their competitors. So by suppressing the foxes who suppress the cats, there might be some indirect positive benefit to cats, and thereby an indirect negative outcome on the prey. So a lot of things going on, and this is an extremely simplified ecosystem that I'm showing. In my systems in Southwest Victoria, there's no dingoes, there's no quolls left, unfortunately. There might be some hanging on the Otway Ranges, but we haven't detected a quoll there in quite some time. So unfortunately, it's this really simplified predator guild, but that's kind of how I based my study in looking at these interactions across these simplified assemblages, and hopefully allowing some sharp focus on the interactions between foxes and cats. I worked on bandicoots and potoroos as well, and I'm not going to present that today, just to keep it short. I'm just going to talk about this kind of like negative interaction between foxes and cats. And this is what's known as the Mesopredator release hypothesis, that when a large apex predator declines, a smaller predator might become more abundant. And in turn, that can have negative effects on prey species. So this was kind of first given a name in '88 in California, where coyotes, which are pretty similar to foxes, where they habitat fragmentation kind of took them out. That was the extinction of the bird species. Yeah, it's a pretty controversial hypothesis. I've since found out doing my PhD on it. I think that's partly because, so it's a bit of a pet peeve of mine when like the word abundant, like I think it is a bit vague. So I really tried to look at this cat-fox interaction following fox control in terms of occurrence, it's like site occupancy, population density, and spatiotemporal activity. Really try to break it up into these like numerical behavioral distribution metrics, I think, just to tackle it from some different angles. And I'm just going to talk about population density and spatiotemporal activity today, just to, again, keep it even shorter. But you can ask me questions about it at the end. I've got some slides tacked on if you'd like. It's not that interesting though. Okay, so let's start with density. So the key question here is, when we control foxes, does that lead to more cats? So this actually hasn't been looked at before. Like no one's actually estimated cat density in response to fox control. There's been a lot of use of like activity indices, but this is kind of like the first attempt at asking this question from a lens of actually estimating cat density. So I stuck out a lot of camera traps, so 6 pairs. So a pair is a landscape with fox control and a landscape without fox control, of around 100 cameras each, surveyed simultaneously. And that allowed me, well, then I then identified the individual cats on those camera traps, which allowed me to use spatial marker site models to estimate cat density in these sites with and without fox control. So this is Southwest Victoria. And let's just focus here in the Glenelg region. So we can see these these black dots here are all the poison bait stations, which get replaced every fortnight. Some really intensive fox control here in the Glenelg region, and that's what the foxes eat and supposedly die. And these red polygons show my camera trapping grids. And so you can see that there's 3 grids, 1, 2, 3. This is actually a river here, which separates these. There's a river here, and so this is a baited landscape, and this is an unbaited landscape. And then these 2 sites are most similar. So I surveyed them at the same time, and then these 2 sites at the same time. As this kind of 3 times replicated control impact experiment, and this is an experiment that's been the Glenelg fox control crew have been they've been using this experiment design for a while, and so yeah, these are the cat density surveys. So this is fox control has been occurring here since 2005, and I surveyed in 2018 and 2019. So like nearly 15 years of fox control here. So the issue here is that we can't really say that we don't know what was happening to cats and foxes prior to fox control commencing. So that's the limitation of this Glenelg region stuff. And then further east in the Otway Ranges, so this is the western section of the Otway Ranges where there's the rainforest. To kind of get around that, I did a before-after control impact experiment where I surveyed these 2 landscapes prior to fox control, and then these bred baits got put in, the black baits got put in, and the fox control started. I surveyed about 6 months after that, and then another 6 or 8. I surveyed 3 times annually. Once before, twice after fox control had started. Cool, and yeah, and we're just noting that there's a bit of variation in like the spatial arrangement of baits, in the fragmentation of some of these forest blocks. Just keep that in your mind. And so I spend what seems like forever looking at cat photos. I first, so cats have these spots and stripes, which are individualistic. And so we can use camera traps to actually identify the individual and therefore use these density models. So I first took apart the different cat coats and made folders of them. These are my favorite, these big swirly ones, they make it really easy to identify. And then because my cameras were spaced close enough together that cats could move in between them, I identified, so we could see cat movements. So this is the same cat, which has appeared on 6 different camera traps. And that's the kind of information we need for these spatial capture type models. So this is the kind of data that you get. So this is the first survey I did in the Glenelg region where there's been long-term fox control. So this is a site with without fox control. This is a site with fox control, and each of these red crosses a camera trap. And each of these dots, colored dots, is an individual cat. And you can see the lines show the movements, like where they were detected on different camera trap sites. So some cats are black, and that's shown by these black circles. So we use the information about cat movements and detectability and behavior based on the ones we can identify, and we kind of assume that black cats are doing the same thing, which I think is pretty reasonable. And the blue ones show cats that I couldn't identify, that they were like tabby cats where I just couldn't identify them. So yeah. 110 camera traps each, surveyed at the same time, first replicate, second replicate in the Glenelg region, and then the third replicate above and below the river. So what do we get here? We got nearly 60 cats in the Glenelg region identified. And this is the cat density estimates that we got, right? So the red here on, let's just look at panel A, the red shows landscapes with fox control, and the blue shows landscapes without fox control. So these are our paired replicates that we were comparing. So this is cat density from 0 to 1 cat per kilometer squared. So you can see that these 2, replicate 1 and replicate 3 fox control sites had quite a bit higher cat density, but not replicate 2. And so this is another way of looking. This is the estimated difference between the sites. So what's the difference of cat density in the baited site relative to the unbaited site? So for the first pair, we see between 2 and 3 times as many cats in the baited site relative to the unbaited site. Absolutely no difference in the second one. And in the third one, we see nearly 4 times as many cats, a higher cat density in the baited site relative to the unbaited site. And so because we're basing our statistical evidence on whether these 95% confidence intervals overlap on, and they, for the first 2, they don't. The second one, absolutely do. So I think, cats higher in 2 of the landscapes, which I think, so there's some good evidence that fox control might be having an effect, but again, we don't know what cats were doing beforehand. So in the Otway Ranges, where this is what cats were doing before fox control, in the site without fox control and the site with fox control, but hadn't happened yet. So you're seeing a lot more cats here in the Otway Ranges. In 2018, where no fox control, but there is fox control in this landscape, don't pay too much attention. It looks like it's increasing heaps of cats, but I actually beefed up the effort a bit here, which is accounted for. And again, resurveyed in 2019. So I got to know these landscapes pretty well. Alrighty, so what happens, what's the cat density estimates here? So the blue dots show the unbaited site, what happened over those 3 years. So no fox control in 2017, and then a bit. And so we're assuming in this before after controlling back experimental design that what's happening in the unbaited site is the natural, what would have been happening in a baited site. So a bit of a decline. Whereas in the site with fox control, we saw a little bit of an increase over those 3 years, kind of like the opposite pattern. And so again, we're looking, so these confidence intervals on this side, these show the estimated difference between the sites. So the difference in cat density in the baited site relative to the unbaited site. And so here we're not assuming, like, the good thing about Backy design is that we're not assuming there was the same cat density in both these grids. What we're actually looking for is overlapping confidence intervals horizontally. So did the difference in cat density between those two grids change over the years we surveyed? And we're attributing that any change in the difference to the Fox control. That's our assumption of our experimental design. And so we don't want to compare 95% confidence intervals because that's a bit too intense. So a 0.5, like a p-value of 0.05 or less is equivalent to like an 83% confidence interval. So we see between 2017 and 2018, even though there was an increase, it's still quite a lot of overlap. And same with 2018 and 2019. But if we compare 2017 to 2019, we see, yeah, an absolute increase. And it's just kind of like reaching that significant. There's no overlap in the 83% confidence intervals. So yeah, there is some weak evidence that cats are increasing in the baited site now. Yeah, it's quite weak, and it's worth keeping in mind that fox control in the Otway Ranges is only monthly relative to fortnightly in the Glenelg region. And there was a pretty big pause. There's like a 5-month pause in bait replacements due to some logistical issues. So while we see I guess it's going in the right direction. And to me, it's kind of like what I would expect. Like, I wouldn't expect a larger increase in cats. Like, this had only been a year and a half since fox control started, and there was a big gap. So yeah, I think, like, yeah, it's kind of what you'd expect to see, I reckon, if Mesopredator release is actually happening. But yeah, good uncertainty. So putting this all together, so why didn't we see that effect in the second landscape, and why are we seeing a weaker effect in the Otway Ranges, other than what I just said? So this is, if we plot for each landscape, each grid, cat density against like fine scale fox occurrence for the landscape, we see that these two, pretty clear negative interactions between where there's high cat density, there's lower fox occupancy, and when there's high fox occurrence probability, there's lower cat density. Yeah, and a bit stronger than Glenelg region. So in that second pair that I did in the Glenelg region where there was an effect, it was a much smaller fragmented site, and so the fox control wasn't having as good as an effect because it was like surrounded by unbaited farmland. So I think foxes are just coming in from that unbaited farmland. So I think this kind of like ties it together and kind of points towards there being a negative association between cat density and fox occurrence. And so, yeah, that's pretty much what I spent like 95% of my effort on my PhD doing. So let that sink in. So even we know, like, there is evidence that foxes are affecting cat density, but between these two sites, we do see there's something else going on, right? Like, cat density is a lot higher in the wet forests, the Otways, relative to the dry forests, the Glenelg region. It's not just about foxes. I think it's about more abundant prey and them actually liking this wet forest environment. And that kind of goes against everything that has been published in the literature. So when I started my PhD, I was reading all these papers and reports who are all saying like feral cats are everywhere except some of the wettest rainforests and uncommon in these closed forests and all this stuff. And I think, well, I wrote a paper just from my 2017 data from the Otways before fox control started. I think just kind of calling that into question. This was the first estimate of cat density in the wet forest, in a cool temperate wet forest, and I think even in an actual forest. We simply hadn't been doing the surveys here, and that makes a lot of sense to me. It's a lot harder to survey cats in these rugged forests. Usually, like previously, we were doing a lot of spotlight surveys, and it just like doesn't, or like sand pad survey, like sand track surveys, but you can't do that in the wet forest. So it's not until we have these camera traps that I think cats are so well studied across Australia, but I still think there's a lot of stuff we don't know about them there's a lot of variation in our ecology and our population dynamics, and that now we're starting to use camera traps and standardize these methods a bit more. I think it's really shining a light on that. So I think, yeah, cats can be cool to study and incredibly frustrating. But I was looking at a lot of cat photos all day, every day, and like you saw in the Otways, like just cats everywhere, like the vast majority of my sites. And so I really didn't think there was much affecting cat occupancy or like cat distribution, but I kept noticing that particular cats going to the same site like at the same time each day, like sometimes like within like 10 minutes, like kind of repeatedly. And so I dedicated a chapter to trying to explore the daily behavioral patterns of cats, like the temporal diel activity patterns. And so I think if you saw Tom's talk last week, he kind of really talked about how cats might be avoiding these larger apex predators or more dominant predators by avoiding them in space or time. So that's kind of the key aim of this chapter I'm about to talk about. So yeah, I just wanted to, first of all, just kind of explore how foxes and cats, their activity changed across these quite heterogeneous landscapes, these regions, 2 regions that I had data on, and whether there was any sign that cats were avoiding foxes in space or in time. So I really wanted to have a joint spatiotemporal model. So I used generalized additive models with these cyclical hour smooths. They're really cool models, which it allows you to join up like 11 p.m. to like 1 a.m. And then you can put some cool interactions of continuous variables such as space and vegetation type. I'm not going to talk about that today though. And then I compared how cats change their dial activity patterns and spatial activity based on how many times you saw foxes on the same camera. And so because we're not relying on individual identification, I collated a whole bunch of more data. So the Glenelg fox control data, which has been monitoring with camera traps since 2013. So much wider, these white dots are camera traps across these sites with fox control. So the red dots and the unbaited sites as well. So yeah, annual surveys there since 2013 and across the entire Otway Ranges as well from Parks Victoria, data from Parks Vic. Yeah, so overall, I think around 1,200 sites across these 2 regions and 3,667 camera trap deployments, which gave me some good data to test these differences in activity. So a bit over 5,000 camera detections of foxes and half of that as cats. And across both these regions, foxes were detected just like raw, naive occupancy estimates, so like 40% of sites and cats 28%. So yeah, good data to run some models on. So we know that predators and species, they have these variable activities across space. It's like what most papers are kind of trying to understand, right? Like, so this is the Otway Ranges as an example. It's just foxes and cats, spatial activity. And we're increasingly kind of studying how the activity patterns vary throughout the day. So on average, this is what foxes are doing. So these dots here show sunrise, this is midday, sunset, and then like the end is like midnight. And this is just like our relative activity, you can kind of interpret it as. So what you should be seeing here is that cats and foxes are pretty much doing the exact same thing on average. When you take all this data together and make an activity pattern curves thing, they're doing the same thing. However, there is spatial variation in that dial activity patterns for these predators. They're, you know, very adaptable, cool little species. It makes sense that they're not having this continuous behavior everywhere. So this shows the variation from that activity pattern across space in the Otways, just as an example, for foxes and cats. And so you can see for foxes, it's a bit annoying to see because it's on different scales, but foxes, like you can see that at each different time of day. So this is just early morning, these kind of like wet forest sites that kind of changing in. I guess I know these sites pretty well, and I can kind of really clearly see when I plot these kind of spatial patterns is the role of vegetation type. So I did some analysis on that, and it basically showed that there's this big kind of like disconnect between what's happening in the wet forests of the Otways and the dry forests. So I made sure that I looked at the cat response to foxes in the dry forest and the wet forest separately. Did I explain everything? Did that make sense? Hope so. Alrighty, so this is what I was saying before. This is what foxes are doing in the Otway's dry forest, and this is like, I did like a separate replicate just to have another test. So yeah, pretty much same thing. In the Glenelg region and the Otways, mostly nocturnal with like crepuscular, I would call this, like just peaking before and after sunrise, sunset. However, in the wet forest, foxes are active like throughout the day, pretty much continuously. Like there's pretty much no pattern happening here, and overall activity and occupancy is really low for foxes in the wet forest as well. So what I did, I ran a model where cat activity could vary non-linearly based on how many times foxes were detected on the camera trap. So this is cats in each of these replicates. So the blue shows activity pattern where there was like no foxes. And so obviously there's a lot of sites with no foxes, so we get some nice confidence intervals. And the red is just showing the maximum fox activity, the change in diel and activity for cats. So you see like much wider uncertainty, which of course, as expected, this is the maximum. But basically in the Glenelg region, you can see that, and in the Otways, in the dry forest, cats are actually becoming more nocturnal. They're more even like, yeah. So like you can kind of compare, like it's what you'd expect, right? If you were a cat and would avoid a fox in the dry vegetation types, you come out during the day. So however, in the Otways, it's kind of like, how would you avoid a fox? But we saw that they really reduced their activity around dawn when there was more foxes. And so like, you know, we didn't see a massive decrease in cat activity, which really hints that cats are probably avoiding foxes in time, not in space. And I think that concurs with a lot of literature that's coming out, which hasn't shown these, like cats are everywhere of Australia. There's really not that much that's actually affecting their distribution, but yeah, seem to be really flexible with their daily activity patterns. And so this is just showing the same pattern, but I just want you to know that it can happen non-linear from the low to high, and we're estimating it all in these in-between sites. Yeah. So yeah, I think this is some good evidence that we're seeing a change in diel activity patterns, and that's based on fox activity. So I guess we don't know for sure, but I'm inferring that this is like an avoidance behavior that they're using. And so if you remember like how much overlap there was on average when we just averaged all this data, like they were doing the same thing. But I think this shows that kind of misses the point, because they're not changing behavior constantly. They're only changing behavior when they have to. So this is kind of a classic landscape of fear type hypothesis. So I think it's really important that we have these joint spatiotemporal models, and we allow for behavioral change. And I think continuous behavioral changes is much better rather than breaking up into day or night. Anyway, so yeah, I think predator activity, like diel activity, is just super variable, and we're really increasing, like all the camera traps, GPSs that we use to monitor these predators has time-stamped information, and it's often scrapped from analyses. But you know, I think there's some cool stories in it. And I think like a shift, if this is true, like if cats are actually shifting to diurnal behavior, like if we suppress fox activity through fox control and cats are becoming more nocturnal, like I would expect that to be affecting the small mammals, like really switching the prey species that cats might be taking. So I think this is definitely worth further investigation. And I think these behavioral changes, it's a lot harder to see how they're going to impact prey relative to numerical changes in density. But I think they could be having, like, I think, you know, we're increasingly understanding that predator behavior like really affects hunting success, and you know, it can have impacts on native prey. Yeah, I found this to be a really flexible, straightforward way that no one really kind of using, I think, to its full potential. I've got some code and stuff online if you want to have a look at it. Just let me know. Yeah, so I might wrap it up there. But in general, I found between both cats and foxes, there's this really big disconnect between what's happening in the wet forest and dry forest. And so for me, it's very like, I don't know, you get a data set and you just want to just take some averages. So I think it's really important we let this data vary spatially, particularly across vegetation types, and don't assume, yeah, same thing's happening. I didn't really show it, but when you spend a lot of time putting out baits and putting them out like really intense in like spatially intensive ways, it's really effective at suppressing fox occupancy. However, we are seeing some signs, a lot of uncertainty, but still some signs that cat density might be increasing and behavioral change. So we need to weigh up any benefit from the having less foxes in the system, probably against having more cats and maybe even more efficient cats. And so I showed that I really don't want this research. I really hope and try and stress that this research, like I don't think this provides any evidence that we should stop fox control. In the Glenelg region, fox control is critically important to the persistence of long-nosed potoroos threatened species here, who seem to be more tied closely to foxes, whereas southern brown bandicoots haven't really benefited. They tend to be like, I think, so maybe there's just differences in, well, there are differences in like how susceptible species are to cats and foxes. So I think you're gonna have species which really strongly benefit from fox control, some species which don't, and then I'm worried that some of the small mammals which often don't get monitored might be losing out. So yeah, I hope my PhD doesn't discourage fox control, but just more encourages like careful monitoring of a wide prey species and cats in response to fox control. And, you know, I think any manager knows that fox control isn't going to save the entire ecosystem. It's one tool we have, and yeah, we might. Sorry, emails come up. Get out of it. This is killing me. I was saying something about don't stop fox control, but just do some more research, but monitor what's actually happening when you do the fox control. And I think like more generally, I think this is pretty robust. Like it's like, yeah, a lot of uncertainty, but like it's still pretty robust experimental evidence for the Mesopredator release hypothesis, which in the past has it hasn't been replicated as much across these different regions. It really hasn't been looked at in terms of population density. So I think my research is cool, and hopefully you think so too.